photosynthesis is two separate but connected metabolic pathways. For this little video, I want to first focus in on the light reactions. Now, light reactions, remember, are inside of the chloroplast organelle, and we're zooming in and focusing in on that third membrane, the thylakoid membrane. So in order to draw the light reactions, I'm first going to draw a straight line to represent the phospholipids with their little hydrophilic heads and their two hydrophobic tails. If you look at the picture in the textbook of the light reactions, what you'll see is that those two phospholipids are stuck together in a bilayer. We're just going to be representing that with a straight line. And essentially, our thylakoid membrane, we're just going to zoom in on one small section of it, and we continue over here because essentially a thylakoid membrane looks like a green pancake. Embedded in our plasma membrane, in this bilayer, we're going to have a series of proteins. Now, our light reactions are always going to start with photosystem 2. Photosystem 2 is a protein with chlorophyll. And what's happening with photosystem 2 is getting hit with sunlight. When photosystem 2 gets hit with sunlight, electrons are going to escape. And when electrons escape, they're going to wiggle through these proteins of the electron transport chain. These are proteins that are embedded in that thylakoid membrane. And so our electrons are going to wiggle through these proteins of the electron transport chain, and those electrons are going to get caught by photosystem 1. Photosystem 1 is also a protein with chlorophyll molecules. Photosystem 1 is also getting hit with sunlight. Now, when sunlight is hitting photosystem 1, it's going to get those electrons excited to a super high energy state. And when these electrons are super excited, they are going to escape again. When they escape again, these electrons are going to get caught by NADP+. Now, NADP+ is just a little bit negative, which is why it can catch those little electrons. When NADP+ catches that electron, it makes this molecule a little bit negative. Hydrogen becomes attracted, and we make NADPH energy. So essentially what we have is we have this one-way flow of electrons from photosystem 2 through the electron transport chain through photosystem 1 to the NADPH energy molecule. This one-way flow of electrons means that at some point photosystem 2 can run out of electrons. So to keep that from happening, what our plant is going to do is it's going to split water, it's going to oxidize water, it's going to remove those hydrogen and remove those electrons. It's going to split water and put the electrons into photosystem 2, which keeps this process going. Now, when we split water, oxygen is released. Since we have a high concentration of oxygen here in our thylakoid space, oxygen is going to move from an area of high concentration to low concentration out in the atmosphere. Oxygen is going to diffuse out of our thylakoid space, out of our chloroplast organelle, and out into the atmosphere. When we split hydrogen, what's going to be left behind are hydrogen ions. When our electrons were wiggling through the proteins of the electron transport chain, hydrogen ions were pulled and pumped into the thylakoid space. Electrons are a little negative, hydrogen are a little positive. So every time an electron goes zip and wiggles through the electron transport chain, hydrogen gets pulled into the thylakoid space. We get a really high concentration of hydrogen ions here in the thylakoid space, low concentration of hydrogen ions in the stroma. Our hydrogen is going to flow through ATP synthase. ATP synthase is a protein, it's an enzyme And when hydrogen flows through, this part of ATP synthase turns and moves every time it turns, it moves, it forces together adenosine diphosphate, ADP, and an inorganic phosphate group, and it makes ATP energy. So a couple more labels to add here before I run through our light reactions one more time. Remember, our line is a thylakoid membrane. Internally, in our half pancake here, we have a thylakoid space, and all of this biochemical goo out here is the stroma of our chloroplast. So one last time, we always start our light reactions with photosystem 2. Photosystem 2 gets hit with sunlight. Sunlight excites electrons. Electrons wiggle through proteins of electron transport chain and are caught by photosystem 1. Photosystem 1 is a protein with chlorophyll. Sun hits, photosystem 1 gets those electrons super excited, they escape again to make NADPH energy. One-way flow of electrons, photosystem 2 through ETC through to photosystem 1 to NADPH means photosystem 2 could run out of electrons. We split water to refill photosystem 2 and keep this process going. When we split water, oxygen is released, hydrogen is left behind. When electrons wiggle through electron transport chain, hydrogen got pulled into the thylakoid space. We get a high concentration of hydrogen in the thylakoid space, low concentration in the stroma. Hydrogen flows through ATP synthase to make ATP. And speaking of energy, we have just been joined by a very energetic dog. Her name is Alta. If you have any questions about the light reactions, please email me and I will try my best to help you out.